root, so that's good.
Okay. Well, good. That's not, I guess, I've never had braces, but that doesn't sound terribly painful. It's not like you had a root canal or anything. Huh.
True, true.
Okay. So what are we doing tonight?
Right now, we're going over like complex numbers.
Okay. So you're off a trig?
Yes,
And you're into,
for now.
and you're doing pre-calc now. Okay.
Yeah.
Okay. Complex numbers are actually pretty easy. If you have a complex number that is in the form a plus bi, something like 3 plus 2i, that would be in that form.
Yeah.
Well, that's the real part. That's the complex part. That's the real coefficient of the complex part. Okay?
Okay.
Now, adding complex numbers is a piece of cake. If I add that to 5 minus I add the real parts, I add the complex parts, I get 8 plus I. Okay?
Okay.
Subtracting them, same thing. Multiplying them, just FOIL them. So multiply these two.
So it would be 15 minus 3i plus 10 minus 2i squared.
What is I squared equal to?
Would it be
If
1?
I is the square root of negative 1,
Yeah.
what is I squared?
1,
Negative 1.
negative 1.
Yeah, if I square both sides here, I get I squared on the left, I get negative 1 on the right.
Okay.
Okay? And that's critical because it means that whenever we run into an I squared, we're looking at a real number. We're not looking at an imaginary number. So
Okay.
if I combine all of these, I get 15 plus 7i minus 2 times minus 1. Well, that becomes plus 2, so now my answer is 17 plus 7i. So multiplying complex numbers is very easy as long as you know how to convert the I squared. I can't do anything with the I. In other words, that's my answer, 17 plus 7i. But I can convert everywhere I have an I squared. Now, the only thing that is hard is division. And that's because it's not really division. No more than if I say divide 1 by the square root of 2, you're not going to actually do that. You're going to multiply top and bottom by the square root of 2 to come up with square root of 2 over 2. Right?
Mm-hmm.
Complex numbers are the same thing. It may look like division, but that's not how I'm going to solve it. I'm going to multiply top and bottom by the conjugate of the bottom. Conjugate is just opposite sign. Since I multiply the bottom by that, I got to multiply the top by that.
Okay.
What's going to happen is the bottom's going to turn into a real number. The top will remain imaginary, but complex numbers are like irrational numbers. Mathematicians don't like to divide by them. So you will never see an answer that has an imaginary number in the denominator. It will always be what you might call rationalized, or what I prefer to call realified. When I multiply top and bottom by the conjugate, I'm turning the bottom into a real number. the bottom is going to become 25 minus I squared, which is plus 1. So the bottom becomes 26. It's now a real number.
So I only do that to the denominator?
When I multiply 5 minus I times 5 plus I get 5 minus I squared.
Okay.
That becomes I get 25 minus I squared. And that becomes 26. Now, I have to FOIL the numerators. In other words, I have to multiply this complex number by 5 plus I, just because I can't multiply the bottom by something without multiplying the top by it also. What's the top become? 15, we did this already. 15, we did something close to this, but this is plus 13I, plus 2I squared. And what does that numerator turn into?
Plus 1. So it would be 16 plus 3.
Not 16. Remember, I squared is negative 1. So whenever you see an I squared, cross it out, put parentheses around it, and put a negative 1 in there.
Okay.
So the numerator becomes 13 plus 13I. See how? In other words, that becomes minus 2.
What about the other I?
What's that?
Do I do anything with the other I?
No. But, as it turns out, even though I randomly picked these numbers, I can divide top and bottom by 13. So what I really have is 1/2 plus 1/2 I. In other words, that is in standard format, whereas this really is not. And it's not in standard format just because I haven't simplified it. This would not be in standard format either. That's not standard format. In other words, I need it to look like A plus BI. Well, this does not look like that. But if I separate it into two fractions, 1/2 plus 1/2 I, now it's in A plus BI. The real part of it is 1/2. The coefficient of the imaginary part is 1/2 also. And I don't know if they've taught you this or not, but when you graph imaginary numbers, the horizontal axis is the real part, the vertical axis is the imaginary part. So if I am graphing that answer 1/2 plus 1/2 I, well, I'm going to go to 1/2 on the real, I'm going to go to 1/2 on the imaginary, and there's my point. That is 1/2 plus 1/2 I.
Can you scroll up a little bit, please? Okay. I don't think my teacher will make me do that.
I'm sorry, what? I didn't quite understand.
So that's standard form?
Yeah, standard form is always A plus BI.
Because that's how she wants it.
You have a real part and you have an imaginary part. And don't combine them like that. In other words, that's not in standard format. I need to split that up into two fractions. I need to split it up into 1/2 plus I over 2, which is the same as 1/2 I. And graphing them you may or may not be doing. You know, imaginary numbers sound hard, but they really aren't. I've virtually taught you the entire spectrum of imaginary numbers in 11 minutes. There is one additional part that they want you to know. Let's go through it. I squared again is what?
1.
Negative 1.
Negative 1.
What's I cubed?
Would it be 1?
Well, it's I squared times I, right?
Yes.
So it's negative I.
True.
Because I squared is negative 1. So I'd have
Times
negative
I.
1 times I, that's negative I. I to the fourth is what?
So negative I times
Think
I.
more in terms of it's I squared times I squared.
Then that would be 1.
Exactly. Okay, now it repeats. Every 4 times it repeats. So I to the 7th is the same as I to the 3rd. I to the 8th is the same as I to the 4th. So that's merely equal to I. That's equal to negative 1. That's equal to negative I. That's equal to 1. So if I said to you, what is I to the 500th power equal to?
500.
Is 500 divisible by 4?
Yes.
Perfectly. So it's equal to 1 also.
Okay. Just fine.
If that exponent is perfectly divisible by 4, then it's equal to 1. I to the 12th is equal to 1. I to the 16th is equal to 1. So if I to the 500th is equal to 1, what is I to the 502nd power equal to?
Negative 1.
Correct. In other words, whatever the remainder is, when you divide that by 4, you get a remainder of 2. So it's equal to I to the 2, which is negative 1.
Okay.
Okay?
And I have another question.
That covers it. I don't think there's anything else about imaginary numbers that you're going to be taught, but go ahead, maybe.
She gave me one where it's okay, so open parenthesis,
Okay?
2 minus I, close parenthesis, open, 3 plus 2I, close, open, 1 minus 4I.
Handle these the same way you would handle a polynomial. In other words, if these were all x's instead of i's, you would multiply that one times that one. Whatever you got as a result, you would multiply it by that. So let's do it. Let's go through that. Multiply the first two.
6 plus 4I
Keep going.
minus 3I,
So that's plus I, okay.
and then minus 2I squared.
Now simplify that.
So I squared equals negative 1.
Correct?
So then that would that make the 2 positive?
Uh-huh.
So then it would be 6 plus 2 plus 1. Since I becomes 1, correct?
No, I doesn't become 1. That I doesn't do anything.
Okay.
But this I squared becomes negative 1.
So it's only the I squared I mess with?
Yes. Well, you could maybe mess with I cubed also. But oddly enough, you don't end up with I. If you get an I cubed, that's negative I. And it's probably worth simplifying to that. But most of the time, you don't get I cubes here. You'll see when we do this one. So this one becomes 8 plus I, right?
Yeah.
Now I'm multiplying it by 1 minus 4I. We're going to have an I squared again, and we're going to still have an I, but we're not going to have any I cubes. So what's this?
That would be 8 minus 32I plus I minus 4I squared.
Simplify.
And the I squared would become negative 1, so it would be 4 So 8 plus 4, which is 12, minus 32, or 31i, minus 31i.
And that's the answer.
Really? Okay.
And notice that even though we started with 3 things, we never had an I cubed. Not as long as we did it step by step. Because this produced an I squared, but that always converts to a real number. You still have an I after you do this first step, but then you're multiplying an I times another expression that has I, and you still only get up to I squared. So it's rare that you ever produce an I cubed or an I to the 4th. But what you're constantly producing is I squareds. And the best way to handle that, make sure you don't get the sign wrong, is to always do this. Take that I squared and just substitute minus 1. Then handle the minus times a minus so it becomes plus 2.
Okay.
Okay. Now, imaginary numbers come up when you're solving equations like this. Obviously, x squared is always going to be positive, right?
Mm-hmm.
Well, if I add a positive number to a positive number, I can't get 0. So this is only going to have imaginary solutions. And I'm going to solve it this way. And I'm going to take the square root of both sides. So x is going to equal what?
X
Plus or minus, first of all. Always start out your answers plus or minus.
square root of 3, negative 3.
That's the first step. Now, whenever you're converting things like that to I, here's the best thing to do. Square root of negative 3 is always the square root of negative 1 times the square root of a positive 3. In other words, always separate it like that. And then you know what that is. That's I. So this becomes square root of 3i.
Okay.
So the answer here is plus or minus square root of 3i. And we usually write the imaginary part afterwards. In other words, even though I split it up into minus 1 and 3, I should have split it up in square root of 3 times square root of minus 1. Makes more sense. But we usually write the I after that. And the only thing you got to be careful with is don't make your radical sign so long that a person can't tell if the I is under the radical or not. It's not.
Okay.
In this case, it is not. It's off by itself. Okay? So imaginary solutions happen when you're solving polynomials that don't have real solutions, like this one. Or even this one. If I plug that into the quadratic formula to try to solve it, I'm going to end up with a negative discriminant. Notice if I try to solve this, I get x equals minus 1, that's negative b, plus or minus the square root of 1 minus 4 times 1 times 10 all over 2. So I got minus 1 plus or minus the square root of negative 39 all over 2. So I have 2 complex solutions only. Let's put that answer in radical form. I mean in standard complex form. What would it be?
So negative 1 plus or minus square root of 39 over 2.
In other words, if you want this in a plus bi, how do we do it?
Would it be negative 1 plus 39?
Okay, you're going to break it up. The a part comes from that. So it's negative 1/2.
Okay.
Still plus or minus
39I squared.
the square root of 39 times I. That's what this is right there. Notice
But
how
isn't I squared equal to
I got it.
negative?
How I got it was doing this. Took the square root of 39 and separated it into the square root of 39 times the square root of minus 1. That's always your first step. Okay? And the only thing that the square root of 39 is prime. Well, it's not prime, but it's simplified. I can't reduce that. Okay? But I can change square root of minus 1 to I. So that becomes square root of 39 times I.
Okay.
And I still have the 2 under that. So I really don't even want to extend the fraction bar all the way over. My answer is minus 1/2 plus or minus root 39 over 2 times I.
Okay.
And again, if I was graphing this answer, the only two numbers I would care about is the horizontal axis is minus 1/2. And the vertical axis is root 39 over 2. Well, root 39 is about 6, so that's going to be 3 and change. So that point right there would be close to where that is. And remember, that's the imaginary, that's the real. When you're graphing.
Okay.
When you're graphing complex numbers that are in standard format. The only numbers I have to graph are that one and that one right there.
I have another problem that I wanted to go over too.
Sure, go ahead.
Open parenthesis, 3 plus I, then closed and squared.
Okay. So all that means is that, right?
Uh-huh.
So let's do it. FOIL it.
9 plus 3I plus 3I plus I squared.
Simplify it.
So then that would be a negative 1. So then it would be 8 plus 6I.
That's your answer.
Okay. Can we do one more division one?
Yeah. Go ahead.
1 second. Let me find them real quick. I think I have one. Okay. 5 plus I over 6 plus I.
So how do I realify this? Remember, this is not really a division problem. It's all my only goal is to get rid of the I in the denominator.
Multiply everything by 6 plus I.
6 minus I, the conjugate.
Oh.
Always the same as what you're looking at, only with an opposite sign. I multiply
That's what I always do?
by that. Yes, that's what you always do whenever you're doing division by complex number. Is that really it's a multiplication problem. Okay? Now, notice why that always gets rid of the imaginary number. We're looking at difference of squares factored. 6 plus I times 6 minus I is 36 minus I squared, which is 37. So we've instantly turned the denominator into a real number, and that's our goal. And then the numerator is going to be whatever it is. What's the numerator going to be?
30 minus 5I, then plus 6I minus I squared.
Simplify.
30 plus negative I squared. Wait, does I go in the back or the front?
Turn that in Or turn I squared into -1 as your first step always.
Okay, so then I would make that into a -1. So
Okay.
then it would be 29
Well,
plus
now you can combine those two. In other words, those are two real numbers there.
29 plus I.
31.
Oh, so you changed the I too.
You
Okay.
change the I squared to -1. Not the negative I squared, but just the I squared. So, in other words, this if I wanted to be exact and make sure I don't make any mistakes, okay, I can combine the two middle terms like that, but now I want to write this as all I'm doing is replacing I squared with -1.
Okay.
And now that becomes 31 plus I all over 37. Still not in standard format. What's standard format for this?
A plus BI.
Which is what for this problem?
It would be
What's A?
31/7
31
plus
over 37.
plus 1
This part of the fraction. Plus what?
plus I.
No. Plus 1 over 37 times I. In other words, what you're doing is you're splitting this fraction up into two pieces. You're splitting it up into that, and you're also splitting it up into that. Same way as if I had 31 plus x all divided by 37 is the same as 31 divided by 37 plus x divided by 37, or 1 over 37 times x.
Okay.
Okay, now, let me just warn you about one thing. A plus B over C is, whether you're talking imaginary numbers or not, that's always true. But what is not true is this. If I have two terms in the denominator, that I cannot split up into this. Doesn't work. You can only split it into two fractions if I have a single term in the denominator.
Okay.
Okay? In other words, 3 over 4 plus 5 is not 3/4 plus 3/5. But 3 plus 4 over 5 is 3/5 plus 4/5.
Okay.
And you almost always have to make this final step, because whenever you're doing imaginary numbers, you're always going to end up with an answer that looks like that. In other words, you don't ever end up with it in standard format. You always have to split that into two pieces.
All right.
All right. Taylor, you have a good day, and I will talk to you next time.
Okay, thank you for accommodating what happened today.
No
Have a
problem.
good day.
You too.